Welcome everyone, and thank you for joining our webinar entitled Governing Technical Debt When the Authors Are Agents. What's today all about? Well, today we'll explore why technical debt is more critical than ever in the age of AI agents, and the principles of catching and controlling it early haven't changed, but they now need to perhaps be applied to agentic workflows. And Tom's going to take us through exactly how to do that. I'm Andrew, your moderator today, and I'm excited to have Tom with us as our presenter. Let me introduce you formally. So joining us today is Tom Howlett. And Tom is Sonar's Director of AI Engineering Engagement. And Tom, you've got over 30 years, would you believe, in software development. You must have started very, very young.
No, I'm just very old.
It spans .com startups in London and New York. It led to product management here, leading product management actually here at Sonar. And today you're focused on helping developers build an efficient agent-centric development cycle without compromising on quality. So Tom, welcome, and let me hand it over to you.
Thank you. Yeah, I'm starting to worry how old that picture is. There's quite a few years have passed since that was taken now. Cool. Okay, so let's pile into it. So we are now a Gartner Magic Quadrant leader, which is super cool. They've done a quadrant on tech debt management, which is obviously an area we've always prided ourselves in. So it's very exciting to be part of this. I kind of asked myself, why did they do it now? What was the big change? And I think, they are very aware of AI and agents potentially having a negative effect on technical debt and kind of raising awareness of that for customers. I think this is important. I think also there was a lot of focus on architecture, and so now architectures are really coming to the forefront as well. We know that agents are pretty good at writing line level code, but it's still kind of a bit of an unknown around creating architectures, and obviously managing architectures is going to be an increasing part of developers' jobs going forward. So yeah, I've done a kind of almost new presentation today. If you've seen any of my previous webinars, hopefully there won't be too much repetition. I think there's one or two slides I've stolen, but hopefully this is all new stuff. So is tech debt still relevant? Big question on everyone's lips. I hear lots of people going, well, I'm not really sure about quality and technical debt now. I've got agents, surely they can just go and fix it. So this is absolutely a key question. Well, let's get into that. So when you first start coding, and if I can cast myself back to 30 years when I first originally got my hands on code and started developing applications, you were super chuffed just to get things working, right? It's you build something, you get it working, you release it, you feel really proud of yourself, and then you spend the next 3 months trying to fix the bugs, trying to kind of add new features that were missing, and it taking a really long time. And why is this? Is because of technical debt, right? So it's not just enough just to do the working code. If you haven't really focused on the quality of the architecture, the foundations, you're constantly kind of battling this tech debt thing, right? And the longer it goes on, the kind of more debt you're paying on that technical debt. So technical debt is kind of super hard to do when you start out, because you don't know what's coming, right? You don't necessarily know how that software is going to be used. You tested it yourself, that seems fine, but you don't know how all the users are going to be using it. You don't know, modern days, you really don't know how it's going to be attacked. This is a increasing problem now. And probably most importantly, you don't know how it's going to change, right? So we all build software, and on day one we think, we're done, and then lots of new requirements come in, and we end up turning it into something else. So as we get experienced, we kind of learn to build really strong, solid foundations that allow us to build on that and change that as things go on. Now, it's I think it's sort of interesting. I did most of my time as a developer, I guess, in the sort of early 2000s and into the 2010s, and it was a time of kind of extreme programming and sort of agile development practices, and sort of software craftsmanship, code craftsmanship was a kind of big deal. And we had TDD, we had pair programming, and there was that craftsmanship kind of culture was almost kind of said, whatever you're building, you build quality into it, kind of thing. Now in the 2020s, there's definitely a big move towards speed, right? Speed of deployment is now a big deal. And I think there's a bit of a conflict between that craftsmanship attitude that we had before and the speed. I think we have to take a pragmatic view on this, to be honest, especially now with agents. We can develop those kind of smaller, less critical applications that potentially won't be maintained a lot very, very fast, right? And to try to apply the same software craftsmanship standards to those is just kind of slowing us down and wasting time. But then on the other end of the scale, we have these big enterprise applications, mission critical, the kind of heart of the organization. And those still require this, you know, for them, the maintainability is absolutely critical. The ability to change, the ability to fix bugs quickly. This is incredibly important. And so we still have to put that effort in there to ensure that those meet the standards. And I think this is something we're just starting to realize now with agents. And while agents will naturally develop those vibe coded internal apps super quickly, they require a lot more to actually get them to write the high quality code that we need in enterprise environments. And I guess that's the difference in tech debt. If we don't do that, we have the tech debt, right? So that's really important. So a few years back at Sonar, we did quite an extensive exercise, having a kind of think about what does software quality really mean, and basically what is quality, what is code that doesn't have tech debt on it. And we created this kind of taxonomy that you see here. And I think actually it's something nice to come back to that now and to start to think about that. We kind of, one of the first things was consistency, right? And what this really helps with is the understanding of the code, right? The comprehension of the code. And if you kind of develop code that's very hard to comprehend, it's then very hard to maintain because you spend all your time trying to understand what you read before. So things like formatting, you know, using conventions, using the same thing again and again, you know, identifiable method names, things like that. They're absolutely critical if you want to be able to comprehend it, you know, and that clarity there. And I think the other thing as well is things being distinct, right? One of the SonarQube measures is duplication. And I know a lot of people pay a lot of attention to that, and I think it's increasingly important, right? If everything is done once, then your software is of reasonable size, and you know where to go if you want to change that piece of functionality. If that functionality is kind of split over multiple places, if it's done multiple times in slightly different ways, whenever you want to make a change, you can't just change it in one place. You have to think about all the different places that might be going on, right? So that distinct and kind of modular is really important. And I think the focus side, right? Focus methods that just do one thing is super critical, right? Again, it makes it maintainable, it makes it easy to understand, it makes it easy to change. So these principles are still really important. I think the big open question is at the moment is how do agents do on these principles, right? Now, if we kind of take agents out of the box, I think they score quite well on some of these attributes and less well on others, right? So we get good kind of formatted code. It's generally quite clear and it's reasonably logical, I would say. And actually there is pretty good completeness, right? In fact, agents will tend to err on being almost over complete. They will put checks in where checks aren't needed. They will put things. So it's almost like there's too much, they're going too far on the completeness sometimes. I think, you know, being conventional and efficient, they're not necessarily big on that unless you kind of set that as a requirement. Now, where they often fall down is this kind of like focus methods, distinct. We see lots of instances of agents kind of duplicating code, creating very similar methods rather than kind of adapting the previous one. And modular, right? If we don't guide them, you won't get nice modularity from an agent, right? I mean, it's unlikely, right? It seems not. I mean, tested, they absolutely will create good tested code if you ask them to, not if you don't ask them to. So I've put this as an orange, right? I think, and actually they can write pretty good tests, but they can also do strange things to tests, like change the test to make the functionality work, which I'm sure people have seen. So they can't necessarily be trusted. I won't go into the responsible side of this. It's slightly kind of off topic here on tech debt, but yeah, on those other ones, I think, agents do reasonably well, but there are some areas where we really need to help them write the right code. And this kind of leads to, well, does the AI actually care about tech debt, right? I mean, if you have your junior programmer, he's not really aware of the problems of tech debt yet. You have the senior programmer, he is, and he very much cares about tech debt, right? If he's a good developer, he'll be thinking about that all the time. Where does the agent sit? Well, the agent is more kind of working, when he comes out of the box, more like the junior programmer, right? They are just really focused on getting the job done, getting the task complete. And why is this, right? So the first thing I think is the agents seem to be very risk adverse, right? If there's something, if there is a new method required and it's very similar to an old one, they won't refactor and extract that method. They will write a new one, right? And then that's kind of them trying to touch the minimum amount of code, right? And I'll often discuss with the agent why it makes different architectural choices like this, and they'll often come back and say, well, I was trying to minimize the changes, right? Minimize the impact of my change, which I guess from a risk and a change kind of risk approach is a reasonable approach, but it has a negative consequence to the long-term maintainability of that code, right? Interestingly, agents seem to feel no pain, right? Well, I mean, this is a big philosophical debate, but assuming that agents feel no pain, they are quite happy to work on some pretty awful code and try to kind of patch the functionality, the new requirement into that code, right? They'll just burn more tokens doing it effectively, and they won't complain. They'll find a way. They'll try and meet your requirements, but obviously, if the code was a mess to start with, the code that they're building on was a real mess, they're just going to kind of make that worse. There's probably a lot of hidden bugs within that code that you haven't seen. It's less likely to be successful, although they kind of will. They'll kind of reach your original requirements. And yeah, so I think we have to be kind of aware of this, right? They don't come back and go, I really should refactor this code before I change it, right? They will just work on that code and try to make it work, right? And then agents don't know what's coming, right? They always seem to assume that the task you give them is going to be the last task you ever give them, right? So they are not thinking about how adaptable that code is for the next task you're going to give them, unless you specify it, right? And I think this was, when I was preparing this talk this week, something that I kind of wanted to get into a bit. I was like, well, what if I actually tell the agent that there are more tasks coming? Now, if you've seen one of my talks before, you'll see that I use this benchmark called Slop Code Bench. Right? I always get the name wrong. Now, Slop Code Bench is a really interesting benchmark. It has a bunch of tasks. There's about 20, 30 tasks available, but they're kind of iterative. And so there's kind of this one is basically a code search engine, and it will search. It will ask it to create a very basic code search, and then it will evaluate that, and then it will add more features, but it won't know that there's more features coming. It certainly won't know what the features are coming. Now, if you were to give it all the features in one go, you'd probably get quite a different solution. But this is a realistic scenario, right? When you're working on a task today or a story today, you don't know what you're going to be working on tomorrow necessarily, or certainly don't know what you're going to be working on in 2 weeks' time. So naturally, an experienced developer will kind of build code that is adaptable for those unknowns that are coming in the future, and the agent won't necessarily do that. But I did 2 runs, one with just build it prompt effectively, and the second run I just added one note to the prompt which said additional tasks will follow the one that build on your solution. The specifics of those future tasks are unknown to you, right? So almost preparing it. And I wanted to see if it would make any difference. And I did 6 runs of each, and if you ever try benchmarking agents or LLMs, you'll know that 6 isn't enough for a conclusive result. There's a lot of variance every time, right? But it gives me an indication that it seems likely that it does take some notice of that, right? It seemed to write slightly more modular codes. It interestingly wrote less code, which was good, right? So I guess it's thinking about the future. It's kind of keeping the code a bit cleaner. It's not bloating the code out as much. And that results in it kind of costing a bit less on tokens as well. So I wouldn't take this as a given. I wouldn't just add this to the end of all your prompts, right, and expect better results. But it's an interesting thing to explore, I think. And it just kind of raises that awareness that this certainly has some sort of impact on the agents, them kind of the fact they don't normally think that there's kind of future things coming. They won't take this as a given. Right? So I guess it's not built into their system prompt, and well, not in this way anyway. So yeah, I thought that was an interesting experiment. Okay, cool. And so even though the agents feel no pain, they do have to deal with the messy code. So you may have seen we published a study recently where we basically ran 2 sets of I think 6 or 7 different projects, and one of them was relatively clean. Well, one was cleaner than the other, right? One had been cleaned with SonarQube and the remediation agent, and one of them had more SonarQube issues on it. And the one that was cleaner, the tasks were able to be completed with less tokens. So as you would expect, in the same way as with a human developer, clean code, easier to work with. And this was a very early study. I think we'll probably go a lot further and get into this a lot more. But it seems evident that clean code is better for agents in a sense, right? Even though they are not prioritizing it. So what do we actually need to do to get the agents to generate debt-free code? Because they're not doing it out of the box, right? Well, I think the first thing is the context, right? I mean, if we go back to our junior developer, he sort of doesn't necessarily have a lot of context, and he doesn't necessarily understand the kind of impact of what they're doing, right? So in the same way that the agent doesn't, right? So if this is a mission critical application that will be maintained for years, it's worth letting the agent know about that, right? And in their agent MD or the Claude MD, you kind of want to set the standard for a start to give yourself a fighting chance, right? It's not going to do everything, but it's crazy to make the assumption that the agent will know this, right? So I think this is one thing that you can absolutely do. And then the standards that you do have for code on that project, you need to tell the agent them, right? Now, this how best to do this, I think we're still kind of learning how to do that. But if there are certain kind of coding standards that you have on that project or certain coding standards that you have in your organization, this is the right time to set it, right? The next thing is architecture, right? A good architecture makes coding a lot easier. But if you don't understand the architecture, it can make coding a lot harder, right? If you have a highly multi-layered abstracted architecture that you have to work on, it can take a long while to kind of unpick and work out exactly where your functionality needs to go. So we need to explain the architecture. We need to give the agent that context it needs to know to use that architecture well and to place the changes that it makes in the right area, right? Now, the agent will kind of try to work this out itself. It will read the code and it will try to kind of reverse engineer into a kind of architectural model. But it's so much easier if you can provide it and you can provide guidelines and you can provide the intent of that architecture, right? Because also your architecture may not be quite as good as you intended, but you can still give it the intent. And so the agent knows where it should put things, even if the previous things aren't always there, right? So again, this is something that could be organizational and this could be project specific. The third thing here is workflow, right? You obviously have a workflow, different projects, different teams probably have slightly different workflows. The first thing I always put in is red green development, right? Let's write unit tests for everything before we write the code. That really seems to work well with agents. It's a relatively cheap thing to do with agents, whereas it's kind of it's more debatable when humans are doing it. And so this works. So if that's something you do, specify that. And then, other stages in the workflow, set those expectations, right? And I think we've kind of experimented this a lot, particularly with our kind of agentic tools that I'll go into later. How you kind of specify a workflow. It's a balance. If you become too specific and try to be too strict, you'll kind of restrain the agent too much. It will almost kind of go through the motions of things without benefiting from them. So you have to find a workflow that really works for the agents. Hooks are one way that you can actually enforce things. When you do this, when you set something in the context, there's no guarantee that the agent will follow those instructions. But when you use hooks, and mechanically put into the events, and they will happen, right? So if you want something that's very specific in your workflow, create a tool for it, put it into a hook, and that tool will kind of run, guaranteed to run. Now, one of the things when we're talking about context is that you put too much context. The more context you put in, the more of it will get ignored, right? It has a limited window. It will kind of, if you tell it too many things, it will start trading them off, right? There's a kind of, it wants to work in a fairly limited context window. One of the ways to get around this, if you have a lot of kind of organizational project specific information to put in, is the context will be too large for Agent MD and Claude MD, but you can put this into documentation in the project, and then the agent instructs the agent that it can find these standards there, and it will move in and it will kind of search that when it needs them. It will kind of learn they're there and reference them when it needs them, right? So if you tell it there, if there's broader documentation, it can then use that documentation without get the information it needs without filling its whole context window up with them, right? So I think this idea of a searchable knowledge base for this stuff is going to become really important to get the context in, because just loading it into your context window doesn't really work, right? And then we've got verification side, right? So with the agent, if we give it context, it will do a good job. If we then allow it to verify that, or give it ways to verify that and give it the feedback, it will do an even better job, right? But you can't do all of the verification at every single point of the development cycle. So this is why we talk about this kind of multi-layered approach, where different steps in verification, like the inner loop, where you're kind of checking for issues as the agent writes the code. That may not be all of the issues that it's checking for, but those are the relevant ones at that point, right? Whereas later on, you might, when the application is deployed, you might do dynamic testing or something like that, right? So it's about having this multi-layered approach that is the right piece of verification for the right stage that software is in, and doing the checks as early as possible. So shifting left as much as possible. And so another way of kind of looking at this is the guide, verify, solve loop. And I think this is kind of useful. We're talking more and more about loops with agents now. The guide part is really interesting. So that's the context that we've just talked about. But I think it's not always just context that's in the agent files or in the files the agent can read. There is also additional human in the loop stuff that you can do here, right? So if you are doing a complex piece of architecture, this is something that you might want to have a discussion with the agent about, right? You'll probably go into design a plan mode and actually start asking questions and start digging in, kind of working out, looking at different options, looking at the trade-offs of different options. This can be an interactive thing between the human developer and the agent. And I'm finding this is, for complex tasks, is the way to work with agents, right? This is the way to get that quality up. I can't just upfront specify a design in the same way that I couldn't, when I was a developer, right? I couldn't just write all of the design up front. It would kind of come out as we were working on the code. And in the same way, the human in the loop with the agent, I think is an important step here, right? For the more complex tasks. The more trivial tasks, we can just let the agent go, and hopefully they have enough context to do a good job of those. So we need to think about the complexity and the criticality of the decisions that are being made at that point. And then again, as soon as we've kind of written some code, as soon as we've made a step, then verify as early as possible that step and solve the issues. The earlier you solve the issues, the less you build on those problems, and the faster it is. They've got all the other context in memory at the time, and so it should be fairly easy to solve that issue, right? So this kind of guide, verify, solve loop all the way through the process is really important. And so what does this mean in practical terms? Well, this is kind of just a flow of an agent, right? So we have this inner loop where the user is asking the agent to do a job. There may be some back and forth on that I haven't included in this diagram. The agent will pull guidelines and architecture. Now we have the product as part of our agentic suite of the context augmentation, which will provide back guidelines and architecture. And then the agent has the context it needs. Now that is specific context to the task in hand, right? The agent it's not just a kind of give me all the architecture, give me all the guidelines. It's focused on the task in hand. And that's critical here, right? It's providing the right context at the right time. The agent then generates the code. It can use tools to analyze the code straight away and then fix any issues on the fly, right? And we see this now with our agentic analysis hook. It's like as the file is saved, initially the agent gets the results back and fixes it. So it's super smooth. Once we get that, it's ready for the PR, and we're good to go. So, yeah. And then the outer loop, right? So we've talked less about that here, but this is what we see from SonarQube, where we have the PR and we're doing those additional checks. And then when the PR happens, we also potentially have remediation agents that are fixing any issues that are found at that point, right? So we are doing a verification step in the PR and we're fixing issues coming in as quickly as possible. In fact, hopefully before the human is there, right? So the human then is doing the final review, the final checks. There's now also AI code review as well, which is kind of finding additional issues, right? And so in terms of tech debt, this is like trying to get all of the tech debt out of the way as early as possible, getting as high a quality standard as we can for as least effort as possible, getting the agent to generate the high value code, high quality code at the beginning. Okay, cool. So that's the kind of generation piece. Talked about the agent. Presuming the agent is doing a reasonably good job, but how can you potentially, if you're say a tech lead or a development manager, how can you see if things are working as they should, right? How successful this is. So obviously SonarQube is one of the areas that SonarQube has always been really strong, and this came out and when we were working on the Gartner quadrant, this kind of reporting. And in fact, we've done a lot recently to enhance this, right? So there is now in customizable dashboards available. So you can create your own dashboards for the things that you want to check. And there's a really nice kind of variety of widgets that you can use for this, which show, can break things down. It can show trends over time, or just counts of issues, right? So these dashboards give us a really high level view of what's going on. And hopefully for the things you care about, you can create a dashboard that really works and allows you to kind of see where the tech debt is. And if we want to kind of dig in below the dashboard, we've got measures, right? So there's the measures section in SonarQube, and this has a kind of a number of different measures that we take, and these are measures of the code, right? This is not about the workflow, this is about the code. Now, this is a kind of nice one that I like, a kind of bubble diagram, which is really about tech debt, right? So on the bottom, where each bubble is a file, effectively, on the bottom is the amount of tech debt in that file, right? So if you were to fix all of the issues on that file, this is potentially how you're going to do it. Now this is human time, not necessarily agent time. So I guess that's something we need to think about, but it's still an interesting measure. And then on the other axis, we've got coverage, right? So if you've got something with a high tech debt and very low coverage, so you're going to be up in the sort of top right-hand corner of this graph, that's a good place to start focusing, right? That's a high risk area we can go into. But then it's not always about files, right? Sometimes it's about areas. And the tree maps in the measures gives us a good way to dig into this, right? So the tree map breaks down initially by modules, and then you can drill into that. You can drill in at the different levels, working through the kind of folder levels to see where the problems are. And so here we can see the API has very low coverage as opposed to the parser on this project, and that's somewhere we'd be looking, right? That's a good way to do this. And then trends over time. Now this one's actually on lines of code trend, and I think this is a metric that we're going to be paying a lot of attention to going forward. Obviously, agents can generate a lot of code. Sometimes this code might be a bit bloated. It might not be kind of proportional to the amount of value that's being generated. So I think keeping an eye on the growth in lines of code is a really interesting metric at the moment, and to see if you're really getting the value out of that additional line of code, because every line of code needs to be maintained, right? And the more we have, the harder it is. And I think we'll start to see this as a smell, where we're just getting a very high growth of lines of code for relatively little functionality, right? Obviously, it's a bit harder to quantify the value of the functionality, but if we're seeing unexpected growth and without seeing the outcomes, we've probably got a problem. And then architecture. So now in SonarQube Cloud, we have a great architecture feature where we can, to start with, you can just dig in and view an architectural model effectively, showing all the dependencies between class. It's laid out in a very clever way, whereas you move from left to right, you get the dependencies tend to flow to the right, which is kind of nice, that you can sort of follow it through left to right. And see, where you've got problems this as well. Obviously, with the current architecture, we also raise issues, right? We start to raise where you've got tangles and other kind of architectural smells that we see that potentially could be problems, right? So this is something to really keep a close eye on. You really don't know how the agent is going to be respecting the architecture, let's say. And another way to do this is to actually specify an intended architecture. Now, if you're working on an existing app, your architecture may not be what was intended, but that doesn't mean we shouldn't define the intended architecture. And the agent can pull this down, and it can respect these boundaries. It can respect these dependencies. It can avoid creating kind of new dependencies that were not intended effectively, and those will get picked up in SonarQube if it does. But obviously, if it reads this into its context on a specific task, it should understand the architecture and not break these in the first place. So I think the intended architecture feature is super cool. It's super cool. Cool. All right. So what happens if you've already got a lot of technical debt on your project? And I think this is something where people are really interested with the impact of agents. Right? I think it's still an interesting question of whether you should start working through that existing technical debt and fixing it. And I think it will be, it will be contextual depending on the situation for your code base at the moment. I mean, is the technical debt causing problems? Is it something that you want to invest in? But the economics with agents has changed, right? And so now Sonar has a remediation agent available. And this remediation agent is able to go through existing issues, and you can select the ones you work on and create PRs with fixes of those. And this remediation agent has specific instructions for fixing Sonar issues, right? So it knows how to do that. It will run checks. It will check it's not creating any new Sonar issues, and it will merge that into a PR. And then you can run all your build checks on that PR, right? So it is now possible to start bulk fixing issues, right? And obviously it's still not risk-free, right? It's not guaranteed that it's not somehow going to change the behavior. But I think if you're selective on the issues that you want to remediate, this is an interesting thing to start exploring now. And here's an example. I think another nice thing with this agent is that it creates some really nice PRs, right? It will talk about the general intent of the PR, talk about why is an issue, what's this change. So kind of like the standard, issue description that you get. But it's very clear, and I think it's very reviewable, and it's something that hopefully you can efficiently start to burn off that technical debt if you have that on existing projects. yeah, so that's mostly on the technical debt. I mean, obviously here I haven't kind of gone into it to start with, but this is kind of really the agent centric development cycle, right? If we're going to work with agents, we don't want to create technical debt, then this development cycle needs to have that guidance and that verification as part of that, right? And I think we have to really think about the agent as central to the process, right? Not just the human developer, which is really key. So yeah, so this agentic cycle, I think it's a key way to reducing technical debt on agent-generated code. And yeah, so we've obviously used some of the new, I've talked about some of the new products that are coming through here. So, so we have agentic analysis, which is doing that verification actually directly on the agent. So that's coming out very shortly, but is available in beta now. We've got the code review tool, which is doing the extra checking to finding more technical debt on top of what's done by the thing. So we've got Guitar there, and then the remediation agent. So, so all of those are now coming through. Cool. Okay. I think that's pretty much it. Andrew, are you there? Do we have any questions?
Hey, Tom. Great, thank you. That was, well, there's a lot to unpack there. Before I forget, you just mentioned guitar. We actually did a webinar on guitar. I think it was last week or the week before. So definitely worth checking out that recording if you're not familiar with guitar. It's our AI native PR code review tool that we've now got available. So it's super cool. Just a small plug there. But yes, Tom, to answer your question, we do have some questions. Let me take a look at the first one. Okay, so a bit of a philosophical question, I think, if you like to start with. So, as models, as the models improve, will they continue to accumulate technical debt, or will we start seeing higher quality code as the models get better?
So I think there's two things to this, right? There is that we know the models generate bugs, vulnerabilities, and they don't necessarily, write good quality code, maintainable code out of the box, right? And so part of that is inherent in the model. And I think, yes, they are improving, and the LLM leaderboard is a good way to kind of track this kind of thing, but we can see there are still issues. So that's absolutely still there. But then I think probably the bigger thing, the thing that we really have to work on as a sort of software development community, is setting the right context to enable the agent to know what the quality standards are, right? So I think however good the model gets, it's still not going to know the context you don't tell it, right? If you don't tell it what good looks like in this situation, if you just give it a prompt to create this feature without describing your quality standards, or what's expected from the code, then it's still gonna do the simplest thing it can do, right? So I think what's going to be really interesting over the coming months, years, isn't so much the change in models, but it's the change in how we set the context for the model. And I think that's a really fascinating area. And then obviously the verification stuff as well. But I guess in theory, if you set the right context and the models get better at following that context, we'll find less and less with the verification, even though it will still be kind of it will still be necessary, right? And that verification is that safety net in a sense, but the context is the thing. If you can get it writing the right code in the first place, then that's the killer, right? That's what's really going to bring productivity to agents, I think.
Well, so then let's take this further. If agents can fix technical debt, do we even need to be worrying about it?
Yeah, another good question. I think some, the best time to fix technical debt is when you write the code in the first place, right? And so however long you write that low quality code, that's always going to have a cost in a sense. Now, maybe you can then go back and fix it. But as anybody knows that's done a big refactoring of a project, the the refactoring is a risky business, right? You're going to uncover new problems, behaviors will change. And if you've got live software out there, that becomes very dangerous. Now, we got good at TDD and things like that in an attempt to refactor in a safe way. And potentially the agent can do that. But there is always risk, right? Whenever you are changing existing code, fundamentally changing the architecture, you're still going to have problems, right? And so there's no guarantee that the agent, however good at, if they do, they are good at refactoring, right? They can do refactoring, but that's not without risk, right? And so it's still better to write the code right in the first place and not accumulate that technical debt than it is have to go through that later and add that additional risk in the same ways you would do when humans were trying to refactor code.
Got it. Thanks, Tom. Okay, let's change tack slightly. So technical debt, it used to be a conversation, with the team lead perhaps, but it seems to be a conversation that's now migrating upwards to perhaps become a board level conversation. So what would you say is driving that shift? Is it AI? Is it regulation? Is it something else? What's behind that, do you think?
Yeah, I think it's a really interesting one, right? I mean, I think for me, it always should have been a board level conversation. There should have been an awareness. And often there's that tension where, writing good quality code without technical debt does take more time, right? Up front. But it's worth it. And often developers in the past were pushed to kind of make compromises, but then they end up paying the price later, and then things slow down, and then the board would say, why aren't we delivering the kind of functionality at the speed we're used to, right? That's always been the problem. So it's interesting, why wasn't it an issue then? And it's necessarily an issue now, right? But I think there is currently so much more unknown about AI generated code, right? There is an awareness that it's bloated. And I mean, we've already seen some of the impacts of that, right? We've seen more live incidents on, less reliability on a lot of different kind of well-known pieces of software that we use every day, and because it's kind of going faster and we're accumulating that technical debt. So, for me, technical debt has always been an economic argument, right? It's always more economic to pay it up front and not kind of accumulate that debt later. But it's very hard to kind of justify. In some ways, I think with the agents and everything moving faster, it's like the horizon is shorter. Things could go very wrong very fast now if you don't get technical debt right. So maybe that's what's driving this conversation at board level. And actually, the fact we're seeing it within a few months of kind of people starting to use agents in anger, we're already seeing the problems that kind of code bloat is causing. So I think this is a very urgent problem to solve now.
We're coming up against time a little bit, but there was one more question I wanted to throw your way. Okay, slightly philosophical. So when an agent is writing the code, who owns the technical debt that it creates? Is it the developer? Is it the team? I mean, who owns that? Who's got the responsibility?
I mean, presuming, it's never the agent, right? For a start. The agent can't take that responsibility. It always falls back to a human at some point.
It doesn't feel pain, as you said.
Yeah, it doesn't feel pain, doesn't get fired. Or maybe it does get fired, right? But maybe it gets swapped for a different agent. I don't know. But I don't think it cares too much. So yeah, it always falls back. It's still the responsibility of the developer. And I think, that's fundamental. I mean, it's interesting what's expected of agents. In some ways, we expect computers to do things perfectly without errors. Agents do a certain amount of errors in the same way as humans make a certain amount of errors, right? And I think we should accept that to some extent, right? We can't expect perfection from the agents, in a sense. It's not going to eliminate all software bugs and all problems in the future. But that responsibility of making sure that it's at least as good as the human developer, and we're not increasing risk without maybe being, a conscious decision, is down to the developer, right? But I think it's a very sensible conversation for the developer to have with the kind of business owners of the application, right? How fast do you want to go? How much risk do you want to take? It's there.
Well answered. Thanks, Tom. I didn't mean to throw you a curveball there, but I think it's a very real question. Listen, Thank you, Tom, so much. I want to be respectful of people's time. We said 45 minutes. It's just gone over. If there were questions that you that came to mind and you still want to pose, our community is a great place to go. It's very vibrant. We can answer questions there, or the community will answer them for you. Tom, thanks so much. I appreciate it. Look forward to the next one. And yeah, see you next time, everybody. Thanks for attending.
Cool. Thank you, everyone.